In this video, I'm going to show you how to find the least common denominator of algebraic fractions. Those are also called rational expressions. This is part one because I'm going to do some more basic problems. And just keep in mind that LCD is the abbreviation for least common denominator. And the least common denominator is the least common multiple of the denominators. I covered least common multiples in my videos on fractions, and there are a lot of different ways to find the least common multiple when you're dealing with numbers. And you can use some of those ways with the algebraic fractions, but I'm going to show you the more traditional way of doing it. All right, here's our first problem. Find the least common denominator for 4 over 9x and 5 over 12x squared. Now, the reason we are interested in finding the least common denominator is because if we were going to add or subtract these fractions, I would need to get a common denominator. So for now, we're just practicing finding the least common denominator, and when we do that, we're really focusing on the denominators, not at all on what's in the numerator. All right, so here's how we could do it. One way is you prime factor the denominators, and when you do that, that means you're going to use exponents if you have a factor list of more than ones. So 9 can be written as 3 squared times x. In other words, that's really 3 times 3 times x. And 12x squared could be written as, well, that's 4 times 3, so that's 2 squared. I'm going to list 2 times 2 is 2 squared times 3 times x squared. All right. So one way of doing this is you take each factor, each different kind of a factor, right? We could just start with the first problem here, the 3. 3 is a factor, right? And so you look and you see there's two places where there's the 3, right? So you list the 3. You're going to use the exponent that's on the highest exponent in any of the fractions. So that'll be a 3 squared. Okay, the next kind of factor there is an x. Okay? And you're going to look and take the highest degree, the highest exponent on any x, and that's over here, the x squared, so I need x squared. The next type of a factor is a 2. And there's only one place where there's a 2 and it has an exponent of 2. The next one is a 3. I've already got the factor of 3. X squared, I've already dealt with the factor of x. So this is the least common denominator. Now, you could multiply the numbers out, 3 times 3 and 2 times 2. That's 9 times 4, or 36 x squared. Right. Another way you can deal with the numerical part, the coefficient, is to do it some other way. So you could just look at the 9 and 12 and say, what's the least common multiple of 9 and 12? What's the smallest number they both go into? And some of you will just come up with 36 right off the spot. So this is another way of doing it. And then between x, there's an x and x squared. You do the one with the highest exponent. You still get 36x squared. So you can get the least common multiple for 9 and 12 in a variety of ways by prime factoring. I showed you a little division method, etc. But basically, you're still going to end up with 36. All right, let's look at another problem. All right, let's try this one. So again, you could say, well, I've got 4 and 6. What's the least common denominator of, or the least common multiple of 4 and 6? What's the smallest number they go into? And you might just come up with 12 on the spot. And the only other kind of factor in here is a y, and you do the one with the highest exponent. So that's a quick way to do it. The other way is, if you're not sure, you can go ahead and do the factoring method I showed you. That's 2 squared times y. This is 2 times 3 times y cubed. And then for the 2, as a factor, you're going to take the highest exponent, which is a 2 squared. For the y, you're going to take the highest exponent, which is y cubed. And for the 3, you've got the highest exponent is 3, and I'll get exactly the same answer. That's still 4 times 3, or 12 y cubed. All right, here's one that's just slightly different because the 10x That's basically factored, unless you wanted to write this as 2 times 5, but the 4x plus 10 is not factored. So before we get the least common multiple, we need to write that in factored form by taking out the greatest common factor. So that's 2 times 2x plus 5. Okay, now if we wrote this all the way down, it would be 2 times 5 times x. So 2x plus 5, that is a factor in its own right. It's not that 2x is a factor, it's not that 5 is a factor. It's the entire quantity 2x plus 5. So if I want to build this up here, I look at the different kinds of factors. There's a 2, and the highest degree is just 1, right? Because you don't have any 2 squared or 2 cubed. There's a 5. And again, there's only one place where there's a 5. Remember, this 5 is totally different. X, all right? Then I move over here. I've already dealt with a 2, and then I have another factor, a 2x plus 5. So none of these have any exponents, and that's how it usually is. So this will give me 2 times 5 times x, that's 10x, times 2x plus 5. So that would be your least common denominator, that one. Now, if you left your 10x as just 10x and your other factor as, I'm looking at the denominators, 2 times 2x plus 5. Again, you could say, well, between 2 and 10, the least common multiple is 10. You don't have to write it out as 2 times 5. So you would say the least common, I'll say the denominator because I'm thinking is 10, and then x is a factor to the first power and 2x plus 5. So you do have a couple ways of looking at it. All right, let's look at this one. We have 3x minus 1 over x plus 4 and 5x over x minus 6. Well, in this case, there are only two factors. There's one factor in the denominator in the first, so that's going to be in the least common denominator to the first power, and we'll also need an x minus 6. This is sort of like the building up method. You have to have both. Whatever's in each denominator has to be in the least common denominator. So if they have nothing in common, each of them, there's just one simple, factor, and one isn't a multiple of each other, or they don't have any common factors, then you just multiply the two together. So here's another one like that. Let's take 3 over x minus 5 and 6 over 5x. Actually, this is really similar. You do have one factor over here. You really have two factors here, a 5 times an x, but in the end, they get multiplied together because you're going to need an x minus 5, you're going to need a 5, and you're going to need an x. So we have 5x times x minus 5. All right, let's look at this one. Before figuring out the least common denominator, we're going to have to factor each denominator. Notice in every single problem, I'm not even paying attention to the numerator at all. We're just finding the least common denominator of the fractions. Now again, I could write this as 2 squared, or I can just leave it as 4. All right, so let's figure this one out. So we need to write the different kinds of factors. I usually start off with what I call the monomial factors. In other words, it's not something in parentheses like x minus 3, which is 4. And there's only one in this case, so we're going to need a 4. Another kind of factor we're going to need is an x plus 3. And the highest exponent on that is just 1. And we're going to need x minus 3, and the highest exponent on that is also 1. So that's the least common denominator, 4 times x plus 3 times x minus 3. All right, we have time for one more. All right, now, when we factor this denominator on the left, it's a perfect square. X minus 2 times x minus 2. But if we write that with the exponents, it would be x minus 2 squared. Okay? All right, now, for this one, so that's how we factor that one. For this one, we pull out a 3, and we have an x minus 2. So when we look for the different kinds of denominators, all right, I need a 3. And the only other factor is the x minus 2. And I need to have the one with the highest exponent. So this will be squared. Okay, now actually I think it's harder finding the least common denominator than going ahead and using it for adding fractions. In a way, that'll be easier. But on the next video, I do some problems where we're looking for at the least common denominator when we have three fractions. So it just steps up the pace a little bit. So if you want, you can look at that, and then we'll be ready for adding and subtracting with different denominators.